Today we'll be working on lesson 2 for solving absolute value inequalities, and that's going to be the regular practice. We're going to start on number 1. I'm going to try to do a couple of practice questions where the absolute value is less than a number or the absolute value is greater than another number. So I'm going to do a couple of questions from the practice sheet, and we're going to start on number 1. Now, remember, every time you have an equation or an inequality, your first step always is to isolate the absolute value. Now, as you can see, the absolute value is isolated. There's nothing being multiplied or added or subtracted, so it is on its own on the left side of your inequality. So the first step is done for you. The next step is to decide what type of relation the inequality is. Is it a less than or equal one? Or is it a greater than or maybe greater than or equal? It's the same thing. So you have to decide whether it's this type or this type. As you can see, the absolute value is less than or equal to 5. So I want you to think of this as a less than with the word and. So as you can see, it's a less than relation. So let me erase this part. Now, what do we do if the absolute value is less than a number? Again, like we did in equations, we have to separate the 5 into a -5 and a 5. Because when they say that the distance is 5, it means you can either go to the left 5 and that's the -5, or you can go to the right 5 and that's the +5. So every single time you have an inequality, okay, you have to decide what type of relation is it. Is it a less than or a greater? If it's a less than, this is how you do it. You try to create a compound inequality, saying that whatever is inside the absolute, which is x minus 18, is going to be between the -5 and the 5. So separate the 5 into a negative and a positive, and whatever is inside the absolute is going to be between -5 and 5. And since it's an equal thing as well, so you have to have less than or equal on both of them. So every time you have a less than relation, you're going to end up with a compound inequality. Compound inequality. And you set whatever is inside the absolute to be between -5 and 5. Now, how do we solve something like this? Remember, you have to isolate the x to be able to know what x is. So you add 18, but now you add 18 to every part of this inequality. So -5 plus 18, that was going to be 13, which is less than or equal to x, which is less than or equal to 23. So that is your compound inequality. Now, every time you have an inequality, remember you have to represent this on the number line. So if this is 0, this is 13, and this is 23, you know that x is going to be between 13 and 23. So you have a line between 13 and 23. Now, since 13 and 23 are included because of the less than and equal sign, so you have to have a solid circle on both of them. Now, what this means is that if you take any number between 13 and 23, which is, let's say, 15, and you plug it back in the inequality, it's going to make sense. So let's try it. 15 minus 18, that's going to give you a -3 inside the absolute. So the absolute value of -3 would become a 3. Is 3 less than or equal to 5? Yes. So your solution makes sense. Okay? Now, to better understand this, let's go to our calculator and let's try to plug this in. So I'm going to put the left side of my inequality on y1. So I'm going to go to second, 0, and get the absolute value. I'm going to put x minus 18 in y1, and I'm going to put the right side of your inequality, which is the 5, in y2, and I'm going to graph it. Now remember, sometimes you have to fix your window if you can't see the whole picture. Now, as you can see, my v is somewhere here in the corner, so you have to fix the y maximum and the x maximum. Let's do that. So go to your window, fix the x maximum to be, like, let's say 40, and the y maximum to be also 40. So as you can see, I'm trying to fix my window to be able to see the whole V shape. Graph. Now, there you go. I can see my V shape, which is the absolute value of x minus 18. And I can see the red line, which is the 5, which is the horizontal line. Now remember, you want the absolute value that is less than or equal to 5, and usually less than means below. So you're interested in the part of the V that's below your red line. As you can see, it's only one piece. And that's why when you separate 5 into the negative and the positive, you want it to be just one piece of inequality, and that's why you put x minus 18 between them. So one piece below the red line, one compound inequality, one line or on your number line. Make sense now? Now let's please go ahead and pause the video and try to do another number on your own. So go ahead and do number 3. Now I don't know about you guys, but I like my variable always to be on the left side. So what I'm going to do is I'm going to rewrite this in a way that I would feel comfortable with it. So I'm going to put absolute value of y plus 5 to be less than or equal to 8. So what I did is I just rewrote this, y plus 5 less than or equal to 8, okay? Now pause the video and try this on your own, and then play the video again to see if you got the right answer. Now I do hope that you tried on your own. So remember, your first step is to isolate the absolute value. Check. The absolute value is on its own on the left side of your inequality. The second step is to decide if it's a less than or a greater inequality. So remember, we're interested with the absolute value. So let's see. The absolute value is less than 8. So it's a less than relation. So I should have one compound inequality, one line on the number line. Divide 8 into a negative 8 and an 8. Always the inequality should be facing that side, as you can see, opening to the right side. And whatever is inside the absolute value is going to be between negative and 8 and 8. So less than means that you have to have a compound inequality. You separate 8 into the negative 8 and the 8, means you're going 8 steps to the left, 8 steps to the right, and whatever is inside the absolute has to be between negative 8 and 8. Again, you solve it the same way. You subtract 5 from all sides, you end up with only a y in the middle. Negative 8 and negative 5, that's a negative 13. 8 minus 5, that's a 3. It means that your y is between negative 13 and 13 and 3. So on the number line, you show me the negative 13 and the 3. As you can see, they're both included since you have an equal sign for both of them. So you need to have a solid circle, filled circle for both of them. And you have to show me that your answer or your solution is going to be between those two. Means any number between negative 13 and 3 will work. So that's the difference between an equality and equation. In equation, you're going to have a max of 2 solutions, or maybe one solution or no solution. In inequality, you're going to have a number of solutions. So as you can see, more than 2. Any number between negative 13 and 3 will work. So let's try. We're going to check 0. Always check to double be more positive that your answer is right. So I'm going to check 0. I'm going to plug it in for x. 0 plus 5 is a 5. Absolute value of 5 is just 5. So is 8 greater than or equal to 5? Yes, so my answer is correct. So this is how you do a less than relation. Now, if you'd like to go ahead and graph it, let's do that. Remember, always graph the part after you isolate your variable. So I'm going to put x plus 5 because I don't have a y, so the x represents the y in this case. So the 8 is going to go in y2. I'm going to graph this. Now that's your V shape. And that's your y equals 8. As you can see, let me fix my window. I want to be able to see the left side better, so I'm going to put negative 30. There you go, that's my better V shape. And that's y equals 8. You want the part of the V that is less than 8. So you want the part of the V that's below the 8. As you can see, it's only one piece. So one compound inequality, one number line. As you can see, like the number over here where they intersect is almost like negative 13. and where they intersect over here is 3, so you know your answer should be between negative 13 and 3, and there you go, it shows. Okay, now let's move on to another part of our lesson, which is when you have the absolute value to be greater than a number. Again, I'm going to rewrite this. I feel more comfortable having the x on the left side. As you can see, x plus 12 is greater than 9, so I'm going to rewrite this. Again, your first step is always to isolate the absolute value. As you can see, it is isolated. Your second step is to decide what type of relation is it. Is it a less than or greater? As you can see, the absolute value is greater than 9. So I'm going to think of it as a greater relation. And the reason why we are saying greater is because I want you to think this of it as an or relation. So we're going to have an either or, either one inequality or another equality, okay? So what does that mean? Again, you have to divide 9 into a 9 and a negative 9. Now what I want you to do is to rewrite this inequality, x plus 12 greater than 9. So there you go, x plus 12 greater than 9. That's going to be your first inequality. You have to rewrite this without the absolute value. Now what you need to do, the other inequality is going to be x plus 12, and you shift this. Instead of greater, you have to put less than, and instead of 9, you have to put negative 9. So that's your or relation. So when you have a greater, think of greater, two different relations. You solve each one separately, and it's going to give you, you'll see that it's going to give you two different lines on your number line going in different directions. So that's why it's an or solution. It means x can be either here or here. We'll see what I mean in a minute. So let's try to solve this one by subtracting 12 from both sides. So x is going to be greater than negative 3. Now again, to solve this one, you have to subtract 12 from both sides. So x is going to be less than negative 21. So we have two different relations. Let's try to graph them. 0 is going to be somewhere here, negative 3 here, negative 21 here. X is greater than negative 3. Negative 3 is not included since you don't have an equal sign. So I'm going to have an open circle on top of negative 3. And x is greater than negative 3. So I represent that by drawing a line to the right. Because as you're going to the right, the number x is going to get greater and greater. Now x less than negative 21, so I'm going to have an open circle on negative 21. Less than negative 21 means I'm going to the left. So as you can see, you have two different lines, each one going in a different direction. So every time you have a greater, you will have two different inequalities. You solve each one separately, and you're going to end up with two different lines on your number line going in different directions. So now it's not between negative 21 and negative 3. It's greater than negative 3 and less than negative 21, two different lines. Now let's see this on the calculator. On y1, I'm going to put x plus 12. So I'm going to go in here. I'm going to put 12. I'm going to go to y2, I'm going to put 9. Let's graph this. This is going to be your V shape. And this is going to be y2, which is y12. Now, you want the absolute value that is greater than 9. It means you want the part of the V that is above. Greater means above 9. Now, so what part of V is above the red line? You have this part, and you have this part. So as you can see, how many parts do you have above the red line? 1, 2. That's why we have 1, 2 inequalities. That's why we have 1, 2 lines, okay? So remember, the steps are the same. Isolate the absolute value. Decide what type of relation it is. If it's less than, then we'll have a compound inequality, a line between two different numbers. Greater means you have two different inequalities, two different lines, okay? Now pause the video and try to do number 6 on your own. Now I do hope you tried this one on your own. Remember, the first step is to isolate the absolute value. So I'm going to add 8 to both sides. I'm going to end up with absolute value of 6x greater than 30. This is my first step. The second step is to decide what type of relation. Is the absolute value less than or the absolute value greater? If it's greater, think of the word greater. It means or. I'm going to have two different relations. The first one's going to be 6x greater than 30, exactly the same thing. And the other one's going to be the opposite. Okay? So you keep 6x. This is going to be shifted, and this is going to be also opposite. You solve each one separately. So divide by 6, divide by 6. X is greater than 5. Divide by 6, divided by 6. X is less than negative 5. So as you can see, you have two different relations. X can be either greater than 5 or less than negative 5. So let's draw this on the number line. There's no equal sign, so you're going to have an open circle on both of them. X greater than 5, it means you're going to the right. X less than negative 5, it means you're going to the left. It means X can either be here or here. Now, what we forgot to do in the first step is we forgot to check. So let's check. Take a number less than negative 5. Let's say negative 7. Plug it in your equation. Always plug it in the main equation. Okay? What was the equation? Minus 8 greater than 22. So 6 times negative 7 is negative 42. Absolute value of negative 42 minus 8 is greater than 22. Negative 42 means absolute value of 42, or the absolute value of a negative number is just 42. So 42 now minus 8 is greater than 22. And yes, it does make sense. The 42 minus 8 is going to give you a number greater than 22. Now take another number that's above 5, let's say 10. Let's plug it in. Okay? So I'm going to do that. 6 times 10 minus 8, is it greater than 22? Let's check. 6 times 10 is going to give you a 60 minus 8, is it greater than 22? Yes. So then the other number that you took also made sense. Always remember to check your solution. So this is how you solve an absolute value inequality. Now what I'm going to do is number 4 and 5 as well. So let's try on number 4. Now number 4, first of all, you need to isolate your inequality, so you have to divide by negative 2. When you divide by a negative number, what happens to the inequality? It's going to shift, and 6 divided by negative 2 is then negative 3. Remember, every time we divide by a negative 2, the inequality shifts. And why did we divide by negative 2? You need to isolate your absolute value. Remember, you cannot distribute the negative 2. Think of the absolute value as brick walls. Nothing goes in, nothing goes out. You divide by negative 2 to isolate it. Now think about it. When is an absolute value greater than a negative number? Always. This is always the case. So this answer is going to be infinite solution. Because, so before you start separating, when you see that absolute value is going to be greater than a negative number, that's an always solution. It's an infinite solution because it's always true. Now in all the other parts, x, or the absolute value, was always greater or smaller than a positive number. When you have a negative number, this is when you need to stop and think. Okay, so I was showing all the other values. So every time you have a negative on the other side, you have to stop and think. If they're saying that the absolute value is greater than a negative number, it's an infinite solution. So let's try to graph it to better see it. So go to y and plug in 3x minus 2. Now you can plug in the main equation, but I always prefer, I feel like it's easier for you to plug in after you isolate the absolute value in the calculator. So let's graph it. That's going to be my V shape, and that's going to be the number line. Now, the question is, you're interested in the part of the V that is above negative 3. Now, what part of the V is above the red line? All of it, as you can see. It's not like above and below. All of the V shape is above the red line, so that's why we have infinite solution. Not like before when the V went through the red line and you had an above and below values. Here you have all of the V shape above the -3 above means greater, and that's why it's infinite solution. So let's go ahead and try number 5. Again, you need to isolate by subtracting 8. Absolute value of 4b plus 1 is less than -8. Now every time, remember, every time you have a negative on the other side, you have to stop and think. Is it an infinite solution or no solution? Okay? But whenever you have a positive number on the other side, you can divide into less than and greater. Here you have to stop and think. When is an absolute value less than a negative number? Never. An absolute value is always positive. It cannot be less than a negative number, so no solution in this case. Again, to better see it, let's go ahead and graph this. So in y1, I'm going to put 4b plus, so 4x plus 1. And in y2, I'm going to put -8. I'm going to graph it, and together we're going to see the part of the absolute value less than means below -8. So that's -8. So what part of the v is below, because you're interested in less than now? What part of the v is below the red line? Nothing is below the red line. It's all above. So there's no part of the v that's below the negative number, -8. So that's no solution. Now I hope that this video was helpful. Please check the answer key for the rest of the practice sheet and study well.